Welcome to NTU's BLAST tutorial. In this tutorial, we will be exploring the functionality of the BLAST tool available at the National Center for Biotechnology information website. BLAST, which stands for Basic Local Alignment Search Tool, allows users to input a sequence and search a biological database for similar homologs that are associated to the sequence that the user has queried. The objectives of this tutorial would include four main objectives. Firstly, the selection of the relevant BLAST program, as there are 5 different types of BLAST programs that serve different purposes. Secondly, the input of the query sequences. Query sequences can either be nucleotide or protein-based and in different formats. Thirdly, the basics of running the BLAST search, in which we will cover the setting up of certain basic parameters. Last but not least, we will look at the analysis of the results and e-value. An explanation of how the results can be interpreted will also be included. We will start the exercise by going to the NCBI website. Key in www.ncbi.nlm.inh.gov in the browser's address bar. Hit the Enter key and it should take you to the home page. To access the BLAST web page, look at the top left-hand corner of the web page where you will find the Resource tab. Click on it. From the drop-down menu, select Homology, and from there, select BLAST. This would then take you to the BLAST homepage. There are basically 5 different programs to select from. The Protein BLAST or BLAST-P for short compares an amino acid query against a protein sequence database, while the Nucleotide BLAST or BLAST-N for short compares a nucleotide query sequence against a nucleotide sequence database. The remaining 3 databases are translated databases that are of a higher level and will not be covered in this tutorial. In short, if I am using a nucleotide sequence as a query, I should use the BLAST-N. And if I am using a protein sequence, then I should use BLAST-P. Let us take a look at the sequence that we will be using for today's exercise. BLAST accepts inputs in 3 different formats. They are namely FASTA sequence, NCBI accession numbers, and GIs. For this exercise, we are only going to look at the commonly used FASTA format. A sequence in FASTA format begins with a single line description followed by lines of sequence data. The description line is distinguished from the sequence data by a greater than symbol in the first line. As you can see from the example used today, it is in a faster format as there is a greater than symbol followed by the title Homo sapien example, and then the sequences. The example used today is obviously a nucleotide sequence as there are only 4 letters ATCG to represent adenine, cytosine, guanine, and thymine of a DNA sequence, unlike a protein sequence that can be made up of 20 different amino acids. As the sequence that we are going to query in this tutorial is a nucleotide sequence, we would select the BLAST-N program. Click on Nucleotide BLAST to open the BLAST-N web page. The query box is where the sequence in question must go. So copy and paste the whole text into the query box. The next step will be to set up some basic search parameters so as to refine the search. Continuing on to the next part would be to set up some basic parameters. The first thing to look at would be the selection of databases. There are many databases to choose from. For today's practice, I will be using the non-redundant database, where entries with identical sequences have been merged. Thus, I would not get recurring sequences in my output. More information on the other databases can be found in the supplementary materials. The subsequent parameter that needs to be changed would be the organism line. This allows users to specify a specific organism to look for matches in. For example, if I wanted to look for matches in rats only, I could just type in the word rat, and the option will be made available to me in the drop-down box. Alternatively, you may choose a group of organisms, for example, mammals. For today's tutorial, I'm going to use the example monkey. So I just typed the word monkey and I will get my option in the drop-down box. Once you have set up those parameters, you are now ready to run a basic BLAST search. Scroll down to the bottom and you will find the BLAST button at the bottom left-hand corner. Click on it and BLAST will start running. It will take some time for the results to be generated, especially when you have multiple queries. After a short wait, you should receive your results, after which we can proceed to the next part to analyze the result. Now that you have received your results, we are going to look at some essential components of the output and try to understand the information presented to us. Right at the top is where users can find basic information about the search conducted. Scrolling just a little down, we would see the graphic summary. This graphic representation is a general impression of the database sequences that matches to the query sequence. The closest matches are shown in the top in red, pink, green, blue, and black bars, representing sequences in decreasing order of similarity. Mousing over an alignment shows basic information in the top at the box at the top. Clicking on it will display the alignment in detail. Moving down, the description section gives information about the actual hits. Essential information such as the total score and e-value can be found here. The total score is sorted from the highest to the lowest, and the expected score is sorted from the lowest to the highest. The total score is derived by summing the scores from all high-scoring segment pairs from the same database sequence. A basic explanation of the e-value would be that the e-value represents the amount of chance that the matches are due to luck. Thus, essentially we are looking at sequences with very low e-values. In general, any sequence that has an e-value of lower than 1 times 10 to the power of -4 can be considered homologous. So essentially, all the hits that we have here are related to our query sequence. No conclusions can be made for any sequence out of this range. And there you have it, a basic analysis of your result.